Yeah, the DB Mock 2018 question 1A. You see, it's quite a simple question, all right? So what happens is you have a car of mass 1,600 newtons and it's running along a straight road which is inclined at angle alpha to the horizontal. So we have an angle alpha, like so. So what this essentially means is we know that sine alpha is, what's it, 20 over 7. So we need to find the adjacent side. So it's going to be 20 squared, take away 7 squared. Then we're going to square root our answer. Just 3 root 39, okay? So cos alpha is 3 root 39 over 20. And sine alpha we already know, which is 7 over 20. Now, what we know here is that alpha has a power dragging up the hill. So it can operate at 10.8 kilowatts or 10,800 watts. Okay. The car experienced a resistance to the motion of 260 newtons. That's all right. But we're also going to take in the weight into consideration as well. So imagine you're a car, you're going straight down, and you weigh 1,600. So it's 1,600 G is your weight. So we're going to have to break you up into two components, perpendicular and parallel. It's the parallel one we're mainly interested in, which is the green one here. Okay, and what the green one will be is that's angle alpha, so it'll be 1,600 G sine alpha. Okie dokie. Now, what is 1,600 G sine alpha? So it's 1,600 multiplied by 9.8, and then sine alpha being 7 over 20. Press the equal sign there. I got 5,488, which, to be honest, I'd be quite happy with. They definitely forgot the G there on the mass of the car, so they made a mistake there, guys. So that'd be 5,488 for me. So I'm going to change this marking scheme. You see there might have been a mistake here. So it's going to be your traction, which is your force powering up the slope. So your T value, and that's being opposed by your resistance, which they said is 2,600 in the opposite direction. And then we also have our 5,488 newtons resisting it downhill. And that all has to equal MA, which is 1,600 times 1,600 times my A value, which is 0.75. And then we have T minus R, which is our 600 and 260, and that's 5,488. I'm going to bring everything over to one side and isolate T on its own. So T equals 1,600 times 0.75 plus 260 plus 5,488, and I get 6,948, which makes sense. And then your force equals P, your power equals T times V. All right, so your pulling power times V. So V equals P over T. So you have a power of 10,800, and you're going to divide it by 6,948. And what you get here, don't know who designed this test, but man, they obviously don't know what they were doing. 6,948. I get a speed of 1.55 meters per second. It's got to be G, guys. They just left out the G, out and out left the G out, which is an issue, okay? So that went for a couple of marks, okay?